In this video, we're going to talk about percentage error calculations. We didn't have examples on the screen, but before we solve anything, I'd like to show you the formula for calculating percentage error. So the general formula for calculating percentage error is percentage error is equal to absolute value of true value minus measured value divided by absolute value of true value times 100 over 1. There are other forms of this formula where the true value is shown as actual value and the measured value is shown as the estimated value. But this is the general formula for percentage error. Let's use this formula to solve the first question. So I'll write solution here. So for the first question, we're told that a student measures the radius of a circle at 1.46 centimeters instead of 1.38 centimeters. Calculate the percentage error. Now from this question, it is clear that the true value of the radius of the circle is 1.38 centimeters. So this is 1.38 centimeters. And then we are told that he actually measured the circle radius to be 1.46 centimeters. So that means the measured value 1.46 centimeters. So that the percentage error here would be equal to absolute value of 1.38 minus 1.46 centimeters divided by absolute value of 1.38 times 100 over 1. This is equal to, remember we have an absolute value here, so this absolute value of, now 1.38 minus 1.46 is equal to minus 0.08 divided by absolute value of 1.38. Now this is times 100. If I take the absolute value of this number, it becomes a positive number. So anytime you take the absolute value of, say, minus 2.1, you get equal to 2.1. If you take the absolute value of a positive number, say 2, it will still be equal to 2. So absolute value of a negative number is a positive number, absolute value of a positive number is a positive number. So that's what will happen here. The absolute value of this number here will be a positive number. This will then become 0.08 divided by 1.38 times 100. If I do the multiplication here, the percentage error will be equal to 5.80% to 2 decimal places. Now let's jump into the second example to help you understand how to solve percentage error better. For the second example, we are told that the weight of sugar was recorded as 8.0 gram instead of 8.2 gram. What is the percentage error? Now from the question, since the weight of the sugar was recorded as 8.0 gram, that tells us that the measured value is 8.0 gram. This was measured as 8.0 gram instead of 8.2 grams. So that tells us that the true value is 8.2 grams. So that our percentage error would be equal to, we use this formula here. So this will be absolute value of true value, which is 8.2, minus measured value, which is 8.0, divided by absolute value of 8.2, and then times 100 over 1. So that this is equal to 8.2 minus 8.0 is 0.2 divided by 8.2 times 100. Now if we do this on our calculator, we get 2.44%. So that our percentage error for the second question is 2.44%. Now this is a particular problem type in percentage error. There's also another kind of problem type that you deal with in percentage error. So let's look at them. So these are the particular questions I was telling you about. For the problem here, we are told to calculate the percentage error if the capacity of the bucket is 7.5 liters to 1 decimal place. I'll first write out solution. So for the first one, the capacity of the bucket is 7.5 liters. So in this case, I will simply write my measurement is equal to 7.5 liters. Now, unlike before, we don't have a true value or a measured value here apart from just the 7.5 liters. The key thing that we can use to solve this kind of percentage error problem is when we are given a limit. So here we are told that the capacity is measured to 1 decimal place. Say if I have 7.5, the 1 decimal place number is the number just after the point. One thing I want to ask myself is, what is 1 unit value of this number? So 1 unit value of a 1 decimal place number is equal to 0.1. So the next thing I want to do is to get a range from the 1 limit number. So if I draw in a number line, and this is my 7.5, if I want to get a range from this 1 unit number of a 1 decimal place, I'll spread it to the left of this number by half and to the right of this number by half. So I'll pick this number and divide it by 2, put half of it here and half of it here. This is in the negative direction of my number line, and this is in the positive direction of my number line. So the half of 0.1 on this direction is 0.05, and half of 0.1 on this direction is 0.05. If you add 0.05 to 7.5, you get something of 7.55 here. We subtract 0.05 from 7.5, you get something of 0.45. So the potential range of values that the buckets could have been is equal to between 4.5 liters to 7.55 liters. Now the error in this case is taking the potential error that we could have gotten is equal to plus minus this number that we got here is plus minus 0.05. So it is basically half of 1 unit of 1 decimal place. Okay, so now to calculate the percentage error in this case, we just say percentage error is equal to error over measurement times 100. So in this case, we just pick 0.05 divided by the measurement here is 7.5 liters, so this will be divided by 7.5 times 100. So that error is equal to, if you do 0.05 divided by 7.5 times 100, you get 0.67%. So this is the percentage error here. Let's look at the second problem. So for the second example, we are told to calculate the percentage error if the mass of the student is 62 kilograms to two significant figures. Alright, my solution again, and here the measurement is equal to 62 kilograms. Just like before, the key thing that can help us find our percentage error is two significant figures. So if we pick out 62 here and we find out the number that is a two significant figure number, this is the first significant figure number, this is the second significant figure number. So the number that we care about is this number. Now, how do we find 1 unit value of this number? So 1 unit value of this number is equal to, if you notice, this is a whole number. So this number holds the value of units times, if this value is the value of units, that means this is simply 1. So if we spread 1 across 62 kilograms, we would have our number line as 62. If we spread 1, half of it here and half of it here, we'll get 0.5 here, we'll get 0.5 here. So if we add 0.5 to 62, you get 62.5. If you subtract 0.5 from 62, you get 61.5. So that the range of values for this our measurement could actually have been something between 61.5 to 62.5. And then our error is simply equal to plus minus 0.5. So from here we can get our percentage error from percentage error is equal to 0.5 divided by 62 times 100. So if we punch these numbers into our calculator, we get 0.81%. Now let's look into extra examples to really help you understand how to solve this kind of percentage error problems. So for this one, we are told that the length of a field is measured as 500 meters. Find the percentage error of the length if the room is measured to, for the first one, nearest meter, for the second one, nearest 10 meter, for the third one, 1 significant figure. So I'll write my solution. Now for the first one, we are told to calculate when the room is to the nearest meter. My measurement is equal to 500 meters. The nearest meter is simply talking about the first number here. Now, from what I said before, this number holds the value of units, this number holds the value of tens, this number holds the value of hundreds from basic math. 1 unit of this value here is simply 1. So if I were to spread it across the measurement of 500 and I draw my number line, this is 500. If I spread 1 unit across this range, half of it here will be 0.5, half of it here will be 0.5. So if I add 0.5 to 500, I get 500.5. If I subtract it from here, I have 499.5. So that my range of values to the nearest meter for this measurement would actually be something around 499.5 to 500.5 meters. Now my error is simply taking this value here. So we say this is plus minus 5, 0.5. And then my percentage error from what we've been doing so far is simply my error divided by my measurement times 100. So this will be 0.5 divided by 500 times 100. And if we punch that into our calculator, we have 0.1% here. So the percentage error to the nearest meter for this number 1 is 0.5%. For the second one, you can pause the video and try to solve it yourself. Before I solve it, let me clean up space. For number 2, we are told to find the percentage error to the nearest 10 meters. Now the number 500, nearest 10 meters, is simply tell us find for this value, because this value is the units number, this value is the tens number, this value is the hundreds number. So for this number, 1 unit of this number is equal to 10. So that if we spread 10 across my number line, if I spread half of it here and half of it here, now half of 10 here is 5, half of 10 here is 5. So if I were to add 5 to 500, I have 505. If I were to subtract 5 from 500, I have 495. So that my range of values, if I were to measure to the nearest 10, should be around 495 to 505 meters. And then my error is equal to plus minus 5. Now my percentage error is equal to, remember, the percentage error is the error divided by the measurement times 100. So the error here is 5 divided by the measurement, which is 500 times 100. If you punch this inside a calculator, we'll notice that we have 1% as our percentage error. Now, for the last example, you can pause the video and try to solve it yourself. But before I do that, I would like to clean up space. So for the last example, we are told to find the percentage error when we are dealing with one significant figure. So the measurement, remember, is 500 meters. If we are dealing with one significant figures for 500 meters, the number that we care about is this number, the first number. Now, 1 unit of this number is simply equal to 100. So that if we have a number line and 500 is at the middle, we spread 100 across 500. If half of it were to go to the negative side of 500, the number here would be 450. If half of it was to go to the positive side, the number here would be 550. So that the range of values for the measurements, if we're measuring to one significant figure, would be 450 to 550. And then our error from all of this is simply equal to 50 plus minus 50. From there, we can get our percentage error by saying this is equal to the error divided by the measurement times 100. The error here is 50 divided by 500 times 100. These 2 zeros can cancel out these 2 zeros here, so that 50 divided by 5 is 10%. That's how to calculate percentage error problems. If you like the video, leave a thumbs up, share with your friends, and subscribe to the channel. Thank you for watching.